Hi, everybody. I am going to keep this start of the week video very short. You're probably quite sick of hearing my voice or watching videos from me at this point. And it's only going to get worse with that. So sorry. But I did want to just touch on a couple of the key ideas from 2D motion and Newton's second law that I think might be very helpful. So for 2D motion, remember that you always want to keep X and Y separate, and that in the X equation, because the acceleration is 0, this is the only equation. So remembering that this is the only X equation, delta X equals VXT, that's going to be very helpful. And then separately, you use the Y equation and making sure to not combine X and Y knowns, right? So just being careful with the directions and everything. So definitely just keeping them separate. This is for when you're doing your 2D projectile motion. For 2D calculus problems, just remember, again, keep X and Y separate. It's a theme throughout our entire course. Let's say, for example, we have some velocity vector where we'd have some Vx and Vy components. We could write it like this, or we could write it in our I hat and J hat notations like that. Those are equivalent ways of writing our 2D vectors. And that if I wanted to get information about the X position or the X acceleration, I just use my, my calculus in that direction. So the acceleration in the X direction is the derivative of the velocity in the X direction. And the position in X is the integral of the velocity in the X direction. And then the same thing in Y, right? So keeping them separate, only bringing them back together when it asks for the magnitude, and remembering that the magnitude of a vector is the square root of the sides, right? So the magnitude of, say, the velocity would be Vx squared plus Vy squared. Just the Pythagorean theorem, the hypotenuse, all the stuff we did with vectors coming on back, and that the angle then is from the inverse tangent, just like we've done before. Okay, so those are the key ideas. Keeping X and Y separate, whether or not you're doing 2D projectile motion or 2D calculus. And then in Newton's second law, what we're going to see is that when you draw a free body diagram, right, you've already seen that you draw your arrows, but very, very, very importantly, you also draw the direction of your acceleration. In this case, this is accelerating towards the right. Say somebody's pulling something along the ground with a rope. And then you choose a direction to call positive. You have to do this in order to make sense of your plus and minus signs. So I'm just going to choose this coordinate system where I'm calling positive Y up and positive X to the right. So if we look then to see what this would look like for our equations of motion, again, I keep X and Y separate throughout the entire course. And the X direction, I need to keep the X component of my tension. So let's add in an angle here, theta. You'd be given that in a real problem. I'd have some component of my tension, Tx, that's along the X direction only. We can see, right, that this is in my positive direction. So I would then go ahead and write positive Tx, which is just equal to T cosine theta. That's the only force I have. So that's the only step that I do in that sum of forces. Now I have to set it equal to plus MA, minus MA, or 0. And again, here I can note that my acceleration is in my positive direction. So I'm going to choose positive MA. So that's my equation of motion in the X direction. Let's go ahead and see what it would look like in the Y direction. Again, we keep our sum of forces and the MA, that whole step, separate. X and Y separate, never combined. In the Y direction, I have my normal force, which is up. I've called positive Y up. So I say positive N, and then I have mg down, which is what I've called negative. So minus mg, and then if I look here, oops, I almost forgot one. And then here we can see that I also have a component of my tension that is up in the y direction. So it's going to be positive ty, which is t sine theta. So I have my 3 normal force, mg, and the component of the tension forces that I've had to sum up. And now I'm going to set it equal to plus ma, minus ma, or 0. And this all, again, depends on my diagram. We can see that my acceleration is not in the y direction. This is when I choose 0. So this is when I say equals 0. And that would give me my 2 equations, one in x, one in y, that I could work with. Okay, you guys are doing amazing keeping up at going through this course. I have built in some breaks in the quizzes and then an actual break over 4th of July weekend. So keep on keeping on. You are doing amazing. This is basically what it takes to get through the course in the summer. So keep it up. I'm going to be on Discord a lot. I'm going to be carrying around my phone, and I turned on the audio notifications for Discord so that you can reach out and ask any questions you have before you go ahead and take quiz 2 today. Remember that you have solutions to the homework problems now, and you have solutions to the check-ins, so you can study those and have those ready while you're doing the quiz. All right, keep up the really hard work, everybody. You're doing great.